inverse functions. Anything that can be done in math can be undone. What a powerful statement. There is no such thing as a one-way mathematical operation. Anything that can be done in math can be undone. And this statement is going to hold true for functions most of the time. And here's what I mean by that. Any function f of x has an inverse function, as long as you follow some rules. I have to say that caveat. So any function f of x has the function f inverse of x, which is how that little -1 is pronounced. It's f inverse of x. That will quote unquote undo f of x. It'll undo all the operations that f of x did to the x. And you guys realize that when you plug an x value into a function, exponents, coefficients, pluses and minuses, those are all just operations done on a number, right? Any operation that can be done in math can be done undone using its inverse operation. So you cancel all the pluses with minuses, you'd cancel all the multiplications with divisions, and you would cancel all the exponents with radicals. So anytime you plug a number in and a y falls out, you should be able to undo those operations by plugging that y in and the x falling back out. Now, a function y equals f of x may or may not have an inverse function according to our IB textbook. But what they mean is without certain restrictions. To understand which functions do have inverses without restrictions, we have to talk about some terminology. We have to talk about functions that are one-to-one and functions that are many-to-one. A one-to-one function is a function where for every x, there is a unique y. Unique meaning that y value will never get reused. And for every y, there is a unique x. So a function is one-to-one if and only if. Oh, it doesn't say that. A function is one-to-one if, and then it says only when. A function is one-to-one if f of a equals b only when f inverse of b equals a every single time.
So it can't be a problem.
It can't be a parabola because a parabola by definition does not have unique y values for its x's. So it's not one-to-one. So does that mean that it doesn't have an inverse? Well. So here's what's going to go on. It says y equals f of x has an inverse function. If it has an inverse function, excuse me, then the new one is denoted by f, what looks like -1 of x. We've already said that's f inverse of x. It must pass the vertical line test. Well, obviously, because if f of x doesn't pass the vertical line test, it's not a function. The new function is the reflection of y equals f of x over the line y equals x. Now, we did that, right? Last week, we were reflecting things over the line, didn't we? Did we or not? None of you remembers doing that?
I think that was pre-calc.
I did it with the pre-calc class. Okay. Well, when you invert a function, you reflect it over the line y equals x. Every x becomes a y, every y becomes an x. That is a reflection over the line y equals x. It satisfies this, and this is important because we just talked about compositions. If you compose f with f inverse in either order, they cancel each other in both orders, and they just leave you with the x. And so the function y equals x is defined as x such, it maps x onto x. We just call this the identity function. Cool beans? It's its own identity. Y equals x, x equals y. I mean, its own identity, its own inverse. Sorry, wrong I word. Well, Reflecting over the line y equals x has the algebraic effect of switching x and y. Do you guys remember back to algebra 1? In order to find, and algebra 2 actually, in order to find an inverse function, you had to switch x and y, and then solve for y again. Okay, well the reason why is because geometrically you were reflecting over the line y equals x. Is this the bottom of the page? Or just for my, right, okay, it's just my panel having a hiccup. There we go. So geometrically, that's what happens when you reflect over the line y equals x. You switch x and y. Really, really important factor here, guys. Please don't overthink this or underthink this. If you switch every x for every y, that means you have also switched the domain and the range. And this is a very important concept. The domain of f is the range of f inverse. The range of f is the domain of f inverse. Range and domain have switched places. So if the domain of f is from 0 to 5, the range of f inverse is from 0 to 5. That's how that works. And the reciprocal function 1 over x is called a self-inverse function. It's not the only self-inverse. There are several of them, but it is its own inverse. Any function that has an inverse and whose graph is symmetrical about the line y equals x is a self-inverse function. So that's what it is. As long as it's symmetric over the line y equals x, then it's a self-inverse. And the reason why is because when you switch x and y, absolutely nothing would have happened if it was symmetric over that line. Okay, have I given a vocabulary word to what that means yet? Let me... Yep. And it doesn't actually ever say it in our textbook, but it says it in other textbooks, and it's important that you could do this. So Kirill, he automatically knew that x squared is not, according to IB, does not have an inverse function. Well, it does have an inverse function as long as we restrict the domain of f of x. But my point is, how did he know that? Well, one, he's a smart cookie. Two, he was in pre-calc last year, and in pre-calc we teach you a test to see if a function has an inverse that is also a function. If it passes that test, we say it is 1 to 1. When you find an inverse, every x becomes a y, correct? Every y becomes an x. So I just said in order for f to have an inverse function, the inverse has to pass the vertical line test, right? The inverse has to be a function, it has to pass the vertical line test. So if the inverse is passing the vertical line test and reflecting over y equals x has the effect of switching x and y, every vertical line on the inverse would be a horizontal line on the original. So the only way that a function has an inverse that is also a function is if the original function passes the horizontal line test. If a function passes the horizontal line test, then its inverse is a function because all of those horizontal lines become vertical lines, and that means your inverse is passing the vertical line test. That is what it means to be 1 to 1. Your book doesn't make you go into that kind of terminology, but it's good to know that kind of stuff. Let's find the inverse of this function. Yay, rational function, 2x plus 1 over x minus 4. We're going to find that inverse. First things first, good old algebra 1, algebra 2, switch x and y. X equals 2y plus 1 over y minus 4. You have to get that y value by itself. You have to get y all by itself. And it is possible. How do we cancel fractions? Yes, reciprocal, but we just want to, but if we multiply by reciprocal, we're still going to have y's in the bottom. So at this point, I just want to cancel the bottom of the fraction. So instead of multiplying by the whole reciprocal, I'm just going to multiply everything by the bottom. I'll distribute this y minus 4 to both sides of the equation. On this side, the y minus 4's will cancel, and on this side, there's going to be x sitting in front of it. Now we distribute our x. Xy minus 4x equals 2y plus 1. I'm out of vertical space, so I'm going to go that way. You know, when you're trying to solve for a variable, you need to get all the instances of that variable on one side, right? Anything that doesn't have that variable needs to go to the other side. So we need all our y's on the same side, all our non-y's to the other side. So I'm going to, let's see, I guess I'll subtract 2y from both sides, and I'll add 4x to both sides. And like I said, I'm out of vertical space, so I'll come over here. I will do this so my people that are in the back can see what's going on. There. On the left, I'm going to have xy minus 2y. On the right, I'm going to have 4x plus 1. We're trying to get y by itself. Ideas. Trying to get that y by itself. What am I going to have to do? No, just y in general. When we're finished, you need to just say y equals. So how do we get that y all alone? Ideas for me? We could do it. We could try to divide by x. But here's the thing. When you divide by x, you have to divide everything by x. So you'd have to divide this by x, which would be great because you would have y alone. But then you'd have to divide this by x, and now you got a minus 2y sitting over an x. So it's not really going to work. And since you did just try to help me, I'm going to give somebody else a chance. What do you think? And by take out a y, what do you mean? You mean, what's that F word? Factor, yeah, here it is. Yeah, y is a GCF, so you can factor y out. You can undistribute the y. I mean, it is, factoring is undistributing. And now you can divide both sides by x minus 2. Your function is y equals 4x plus 1 over x minus 2. Now let's see who's got big brains. What is the range of f inverse? So let me write. Michael, can you say that again, please? And care to enlighten the class how you found that range of f inverse that fast? Oh, it's the domain of the original. And 4 is not allowed to exist on the original function because it's a vertical asymptote. So the vertical asymptote of the original function is the horizontal asymptote of its inverse. Yes, sir.
Did you just say to distribute infinity?
What? No. Distributive. I didn't even say the word distribute.
What do we just distribute infinity? Real quick.
No, what? I didn't even say the word distribute. No. So what we did, what he did is I asked him, what is the range of this inverse? And he said the range of this inverse must be the domain of the original. And I said, yeah. So the original has a domain of all real numbers except for 4. So we know that the range of the inverse is negative infinity to 4 and from 4 to positive infinity. Cool beans? Cool beans. Great. Flip them. Boink. Yeah, there's stuff on the back. No, it's not the end of the packet. We got a whole other lesson to do. Not today. Yeah. Tomorrow's lesson is the last lesson. Shucks, shoot, darn, look at that. See, we took so much time on homework, we're not going to be able to finish these notes. Oh my gosh, what are we going to do? Well, we'll just finish them tomorrow, and we'll still finish the packet tomorrow, so I'm really not concerned. What homework? You mean tonight's homework? Well, think about it. If the lesson's not done, I'm not going to make the homework due tomorrow, right? So we'll just push the homework back by a day. But here's what this means, though. The next day, you have double homework. So you should probably try to do it tonight because you got, a test review coming up soon.